Hello everyone, it's James here. 안녕하세요, 제임스 송입니다. 자, 이번 비디오는 지난 비디오에 이어서 SAT 특강 Reading Part Passage 3, Science Passage 문제풀이 22번부터 31번까지 문제를 하나씩 완벽하게 풀어보겠습니다. 자, 한번 가보죠. 자, 조금 크게 하고요. 22번. The authors use the word backbone in line 3 and 39 to indicate that. 자, 그러니까 바로 지난 비디오를 보셨으면은 line 3에서 backbone이 써져 있었던 의미는 molecule is a very long chain. The backbone of it is regular alteration of sugar and phosphate groups. 그러니까 sugar and phosphate group이 regular alteration을 가지고 있는 게 chain의 backbone이다. So it's a sugar and phosphate group. In regular alteration is a backbone. 그리고 line 37에서는 어떻게 나왔나 다시 한번 볼까요? (39이네요) 죄송합니다. 39. The phosphate sugar backbone, yeah, so it's the same thing. Backbone is regular alteration of phosphate and sugar. So phosphate sugar backbone. 그쵸? So can't get this wrong. Right. The author used the word backbone in line 3 and 39 to indicate that only very long chain of DNA can be taken from an organism with spinal column. Totally off topic. So it's about sugar and phosphate. Main structure of a chain, yeah, main structure, backbone, synonym. In a DNA molecule is composed of repeating unit. So this could be the answer. Regular, yeah, what was the word? Sorry. Regular alteration. There you go. Regular alteration is same as repeating. And units are sugar and phosphate. So B could be the answer, although B does not, state sugar and phosphate. C, a chain in DNA molecule consists entirely of phosphate groups or of sugar. 자, C 정말 it's a great bad answer, right? Because the question is asking you, right? 질문은 backbone이 말하는 게 무엇이냐? 그러니까 이게 sugar and phosphate groups를 얘기하는 거잖아요, 결국. 근데 여기에 이제 phosphate and sugar 이렇게 나오면서 답이네 하면서 바로 C를 덥석 물게끔 이렇게 함정을 파놓은 거죠. 근데 요 단어를 하나씩 다 읽어볼게요. A chain in a DNA molecule consists entirely, there you go. All right? 함정이죠. Entirely of phosphate groups or of sugars. 그러니까 backbone은 phosphate이랑 sugar랑만으로 이루어진 게 맞지만 요 내용은 질문에 즉답을 하고 있지 않죠. 그죠? 그러니까 backbone만 얘기한 게 아니라 chain in, 그러니까 whole chain, right? Chain in DNA molecule consists of phosphate, sugar, and bases that are attached to the sugar. 맞죠? 그쵸? 근데 whole chain 말고 backbone만 보면 phosphate group이랑 sugar죠. 그러니까 C는 잘못된 답인 거죠. 이해되시죠? 네, 그러니까 question is asking about what are the backbones? Backbone. What is the backbone? All right? So backbone consists of phosphate groups and the sugar. But the answer is saying a chain, not just the backbone, a chain in a DNA molecule consists entirely. So this is wrong. Okay? So very, very good, bad answer. So it looks like B is the right answer, but let's check D. Nitrogenous bases from the main, so base has nothing to do with the backbone. It's already off topic. 그죠? Base, backbone is all about sugar and phosphate groups in regular alteration. 그래서 repeating units 이렇게 대명사로 pronoun으로 repeating units가 regular alteration을 paraphrase 했다는 거를 캐치를 하셨어야 돼요. 그래서 21번 B, C가 아니고요. 22번. I'm sorry. Number 23. Student claims that nitrogenous base pair randomly with one another. 완전히 randomly라고는 볼 수는 없죠. 왜냐하면은 pyrine이랑 pyrimidin이랑 하나씩 들어가야 되고, 뭐 예를 들어서 adenin이랑 thymine이랑만 페어될 수 있고, guanine이랑 뭐였죠? cytosine? 예, 이렇게만 될 수 있으니까 완전 랜덤하다고 볼 수는 없죠. 그런데 a student claims, student가 claim을 해요. Pairs randomly with one another. Which of the following statement in the passage contradicts the student's claim? 그러면은 randomly 페어 되는 건 아니야 라는 내용을 찾으면은 되겠죠. 그쵸? 5, 6, and 9, 10. 한번 봅시다. 5, 6. To each sugar is attached to a nitrogenous base, which can be 4 different types. 그러니까 이것만 봤을 때 randomly인지 randomly 아닌지는 아예 정보가 없죠. So nothing answer. A. 9, 10. So far as it is now, the sequence of bases along the chain is irregular. 그러니까 irregular한데 regular하진 않는데 이게 완벽하게 랜덤하게 irregular한지 irregular한 거 안에서도 뭔가 바운더리가 있는지 뭔가 룰이 있는지 뭐 그건 우리가 알 수가 없죠. 90만 읽어서는. 그리고 우리가 지난 비디오에서 읽었듯이 irregular 하지만 랜덤하지 않죠. 예, 룰이 있죠. 하나씩 들어가야 되잖아요. 그렇죠? 예, 그러니까 A랑 B는 아니네요. A랑 B는 아니고 23에서 25 아니면 27에서 29 봅시다. 23에서 25. The bases are joined together in pairs. A single base from one chain being hydrogen bond to a single base from the other. Wow, we're getting a bit warmer. 그죠? 뭔가 이거 랜덤 아니야 이런 내용인 것 같은데. 그죠? 그럼 27에서 29도 읽어보면서 비교해 볼게요. 방금 전이 답변 C, 그럼 답변 D, 27 to 29. One member of a pair must be purine and the other a pyrimidine in order to bridge between the two chains. Bang! 그죠? 그러니까 다시 이제 비교해 봅시다. 되게 쉽죠? 네. A나 B보다는 C가 낫지만 23에서 25는 The bases are joined together in pairs, single base from one chain being hydrogen bonded to a single base from the other. 여기에서는 이것도 nothing answer인 게 생각을 해보면은 23에서 25만 읽고 이게 랜덤하게 arrange가 되어 있는지 아닌지를 알 수는 없어요. 그런데 27에서 29 answer D 여기서 완벽하게 랜덤이 아니다라는 게 나오는 게 one member of pair must be purine. Okay? So it's not random. And the other one, the other member has to be a pyrimidine. So chance of being randomly arranged is completely out the window. 그죠? 랜덤 할 수 없어요. 절대로. 그래서 23번 D. 24번. In a second paragraph, what do authors claim to be the feature of biological interest? 벌써 알 것 같죠? Two chains. 왜냐면 우리가 잘 읽었으니까. 근데 더블 체크 한번 해볼게요. First feature, yeah. First feature of our structure of biological interest is that it has two chains, not one. And it explained over, two times and elaborates the detail to confirm that it has two chains, not one. 그쵸? 네, 여기 너무 대놓고 나와 있죠? 자, 그럼 답변을 맞춰봅시다. A, chemical formula of, we don't know the chemical formula. It's just two chains, not one. The common fiber axis, in one common fiber axis, there exists two chains. So importance is there are two chains, not one. 이건 evidence로 쓴 거고, 그러니까 24번 D. Consisting of two chains. Bang! 자, 기분이 좋죠? 읽을 때부터 이미 이거 질문에 100% 나올 거야. 이렇게 생각했던 게 나와주고 있어요. 왜? 사이언스 패시지니까. 그죠? 뻔하다는 거죠. 문제가 잘 읽으면. 25번. The author's main purpose of including the information about X-ray evidence and the density. 이거는 to prove, use it as evidence. So it's not just a hunch, guess, assumption. This is hard facts. This is hard data, hard evidence. Right? 자, 같이 읽었었죠? 자, 그러면은 찾아봅시다. 어떤 내용을 증명할 때 엑스레이를 사용했었죠? 백본이고 베이스가 있고 쭉쭉쭉쭉 있고요. The sequence of base along the chain is irregular. 여기까지는 엑스레이를 에비던스로 아직 사용하진 않았죠. 자, 그러면 from line 12, first feature, one chain, fiber axis, assume that since there was only one chain in the chemical formula, there would only be a one structural unit. There you go. However, the density was checked by X-ray, right? We remember reading this, right? 자, 그러니까 이게 two chain이라는 게 너무 중요해서 어떻게 proof 했는지까지 여기 나왔었죠. 강조해서. However, the density taken with the X-ray evidence, so this is a confirmation, hard data, suggests very strongly that there are two chains, not one. So X-ray and density are used to confirm that there are two chains with hard evidence, as hard evidence, right? 자, 그럼 답변을 골라보도록 합시다. A, establish that DNA is the molecule that carries the genetic information. Totally off topic. It's used as evidence to confirm there are two chains. Present an alternate hypothesis. It's not a hypothesis. It's just confirming and used as evidence. So it's off topic as well. And if you read more, it's even more off topic. C, provide support. So far, so good. Use as evidence for the author's claim about the number of chains, two chains. There are two chains, not one. And these two are used as the support. 그죠? Same as evidence. 맞죠? So 25 has to be C. Let's check D. Confirm the relationship between density of DNA. It's not density of DNA. Density is used as evidence to confirm there are two chains. So D is also off topic. 맞죠? 자, 26번 갑니다. Based on the passage, the author's statement, if a pair consisted of two purines, for example, there would not be room for it. 자, 요거 읽으신 거 기억나죠? 그러니까 그 위에 퓨린이랑 퓨린 하나, pyrimidine 하나씩 해야 된다. 퓨린만 두 개가 있거나 페어가 pyrimidin만 두 개가 있거나 되면은 it will not fit. 한 다음에 약간 analogy로 example로 더 구체적으로 이런 문장이 나왔었었죠. 자, 체크해 봅시다. 2930. So let's read for the context from line 25. Okay? All the way down to 30. So important point is that only certain pair of base will fit into the structure. One member of a pair must be purine and the other pyrimidine in order to bridge between the two chains. If a pair consists of two purines, so purine-purine pair, for example, there would not be room for it. So it's not going to fit. It's not going to have enough space. So would not be room for it means would not have enough room to fit it, right? Fit it, right? So 스페이스가 부족할 거다. 이제 이런 뜻으로 쓰인 거죠. 퓨린이 두 개면 스페이스가 부족해서 딱 핏이 안 될 거다. 오케이? 자, 그럼 어떤 결론을 낼 수 있나요? Inference. A. That a pair of purines is going to be too big for that space to be fitted. Would be larger than the space between a sugar and phosphate group. It has nothing to do with the space between sugar and phosphate group. Is the pair of base to be fitted as bases, right? So between sugar and phosphate group에 지금 fit을 하려는 게 아니죠. hydrogen bonds로 두 개가 페어가 돼야 되는 거죠. 그러니까 sugar and phosphate group 사이에 전혀 상관이 없는 얘기예요. Implies that a pair of purine would be larger than a pair consisting of purine and pyrimidine. 그럴 수 있겠죠? Inference question이면. 왜냐하면 there would not be room for it, enough room. It's going to be too big. 그러니까 literally 이거를 독해를 하면은 퓨린만 두 개가 들어가 있으면은 공간이 부족할 거다라는 건 너무 크다는 거죠. 근데 퓨린 하나, pyrimidine 하나가 되면은 페어가 fit 할 수 있잖아요. 그죠? 그러니까 퓨린만 두 개가 있으면은 퓨린이랑 pyrimidin이랑 같이 페어 있는 것보다 더 크다고 볼 수 있겠죠. 왜냐하면 퓨린만 두 개가 있으면 공간이 부족해. 이랬으니까. 그래서 딱 fit 하려면 퓨린만 두 개가 있으면 안 되고 퓨린 하나, pyrimidine 하나, 하나씩 있어야 돼. 그러니까 네, B 맞는 이해죠? 그쵸? 이 문장에 대해서. C. Pyrimidine would be larger than a pair of purines. 이건 모르죠, 우리가. 그러니까 pyrimidine 페어랑 purine 페어가 붙었을 때 뭐가 더 큰지는 알 수가 없고 왜냐하면 패세지에서는 퓨린이랑 pyrimidin이랑 하나씩 들어가야 되고 퓨린만 두 개가 들어가면은 공간이 부족하다고 했으니까 그쵸? C는 우리가 알 수가 없고 B는 맞다고 볼 수가 있죠. 그죠? 그냥 이 얘기를 하는 거니까 정확하게 똑같이 그죠? Right? D. Consisting of a purine and pyrimidine would be larger than a pair of 이건 반대죠. 그쵸? 그러니까 이렇게 페어되는 게 이렇게 페어되는 것보다 더 작겠죠. 그리고 퓨린은 알 수가 있는데 지문에 정확하게 써져 있으니까 뭐 사실 pyrimidine 페어는 알 수도 없어요. 정확하게 써져 있지가 않기 때문에 뭐 너무 작아서 그 사이즈에 안 맞아서 헐거워서 핏이 안 된다라고 볼 수도 있고 그건 우리가 모르는 거예요. 이거는. 그죠? 그러니까 이거에 대한 직접적인 언급은 아예 없다. 그러니까 답은 B가 돼야 되겠죠. 그죠? 네. (27) The author's use of the words exact, specific, and complement in 49 to 49, 47, 죄송합니다. 47 to 49. 자, 그러면 47 to 49의 이 세 단어를 한번 찾아봅시다. In the final paragraph, functions mainly to. 자, 한번 볼까요, 먼저? 47, 49. 오케이. 47, 49. 여기서부터 읽을게요. One could write down the exact order. So order is exact because specific pairing, right? Of the basis on the other one because of the specific, so exact and specific, right? Pairing. Thus, one chain is, as it were, the complement of the other. 그죠? 네, 그러니까 오다가 exact 하니까 specific pairing이 되어서 그 각자의 베이스가 it complements each other, right? One chain complements the other because it has different base in a specific pairing in exact order, okay? And it is this feature, 자, 그러니까 이렇게 돼서 complement를 하니까, 그러니까 complement of each other가 되는 이유가 여기서부터 exact order of the base on the other one because of the specific pairing. So, thus, it complements each other, right? 그래서, and it is this feature, so exact order, specific pairing that makes complementary to each other. Okay, so making complementary to each other is the feature that they're talking about. It is this feature which suggests how DNA might duplicate itself. 그죠? 그러니까 exact order로 specific pairing이 돼서 complement of each other가 됐기 때문에 이 특징이 DNA를 duplicate 하게 해준다. 그 내용이네요. 그죠? The author uses words, exact, specific, complement in the final paragraph function mainly to convey what message, right? In order to convey what message, what's the purpose of it? 자, A, confirm that nucleotide sequence are known for most molecule of DNA. 아니죠. 이 얘기한 이유는 complement each other가 최종적으로 돼서 그게 DNA를 duplicate 해주는 최종적인 결과를 가져온다. 이 뜻이죠. 그러니까 A랑은 전혀 뜻이 다르고. B. Counter the claim that sequence of bases along the chain can occur in any order. 말도 안 되는 소리죠. 이건 큰일 납니다. It's not exact. It's not specific pairing. I mean, this is totally opposite to the answer. C. Support the claim that phosphate sugar backbone. 이거 상관없는데 지금. 그죠? Backbone of the author model is completely regular. 이 얘기가 아니죠. 그죠? 그러니까 이렇게 돼서 complement to each other 돼서 최종적으로 DNA를 duplicate 하는 최종 결과를 영향력을 만들어 주는 거다라는 얘기죠. Hopefully D is the answer. Emphasize how one chain of DNA may serve as a template to be copied. Served as a template to be copied. 이거 뭐로 paraphrase 할 수 있어요? Duplicate. 기가 막힙니다. 기가 막히죠? 그죠? 이제 이런 식으로 문제를 내는 거예요. 자, 더블 체크 한번 하고 갈까요? Right? What's the purpose? So, as I said several times now, complement of the other and this feature which suggests how DNA duplicate itself. Right? So this feature of complement each other at the end, duplicate DNA. So duplicate is paraphrased as served as a template to be copied during DNA replication. 아시겠죠? 그쵸? 네, 그러니까 이게 duplicate. Right? Beautiful. Perfect. Nothing hard so far. 28. Based on the table and the passage, which choice gives the correct percentage of the purines? So purines is adenine and what was it? Guanine, wasn't it? Let me double check. I shouldn't make fool out of myself. So purine is, sorry, I'll be quick. Purine is adenine and guanine. That's purines. Yeah. Yeah, adenine and guanine. Yep, I knew it. So yeast DNA, adenine and guanine. Adenine and guanine. Okay. Yeast, right? Adenine and guanine, right? So 31.1, 31.3 and 18.7. Very easy. 31.3, 18.7. Yeah, bang. All right, 28C. 29. Do the data in the table support the author's proposed pairing of the bases in DNA? Okay, so let's look at the answer choices first and go back to the data and solve the question backwards. All right. Okay, so yes, because of each given organism, the percentage of adenine is closest to the percentage of thymine. So adenine and thymine have to pair together as one, right? Purine and pyrimidine, right? And the percentage of guanine, which is purine, is closest to the percentage of cytosine. So they have to be closest together. So that's why they pair up as one purine, one pyrimidine. Yeah, makes sense. And yeah, this logically makes sense. So I will go to the table and see whether that's the case as well. So that makes sense based on the passage, but let's look at the numbers. So adenine and thymine pretty similar, right? And guanine and cytosine, yeah, it's a closest, right? So these two are closest, these two are closest. Octopus, yep, definitely. These two are the same, right? These two very close, very close, very close, very close. Yep. 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 Yeah. Okay. So, yeah, adenine and thymine relatively closest with each other, while guanine and cytosines are closest to each other as well. So A looks okay. I think A is the answer. But let's continue, double check. Yeah, let me make it a little bit bigger. Question 29. So I think A is very strong. B, yes, because of each given organism, the percentage of adenine is closest to the percentage of guanine. This is not true. like this content is wrong because adenine is closest to the thymine as we checked in the table. So it's a wrong information. So B is out. C, no. Because for each given organism, the percentage of adenine is closest to the percentage of thymine, and the percentage of guanine is the closest to percentage of cytosine. So, very interesting. So, explanation is the same as A, but the answer is no. So, is it yes or no? Think about it. Think about it. Is it yes or no? So, explanations are the same. So should it be yes? It supports the author's proposed pairing or not? Of course, it's yes, because it's closest so that, you know, they can pair up rather than it's closest so they cannot pair up or they should not pair up or they do not pair up. It's nonsense, right? Of course, it's yes. Because adenine and thymine must pair up together, and they are the closest as well. And guanine and cytosine must pair up according to the passage. Yeah? 맞잖아요. 그죠? 네, 그러니까 yes가 돼야죠. 왜냐하면 얘네 둘이 페어업이 안 된다 그러면은 노지만 둘이 페어업이 되잖아요. 패세지에서. 그리고 테이블에서 percentage figure는 되게 비슷하죠. 그러니까 당연히 yes가 돼야죠. Because they do indeed pair up. Alright? So C does not make sense. Alright? D, no. Because for each given organism, the percentage of adenine is closest to the percentage guanine. So this is even worse than B. Alright? It's wrong information. Plus, no is actually wrong answer. Should be yes. Because A is the right answer, right? Beautiful. All right, 2 more questions to go, right? 31 and 32 is history. All right, question 30. Okay, so 29 is A, okay? Question 30. According to the table, which of the following pairs of the base percentages in sea urchin DNA provides evidence in support of the answer to the previous question? Wow. Wow. Okay, so very tricky. So according to the previous question, adenine and thymine, which pair up, need to be closest together, and guanine and cytosine, which need to pair up and must be closest together. So let's look at the numbers. So we need to write this down because we need to go up and down. So A is 17.3 and 17.7. B is 17.3 and 32.1. It's already very far away. 17.3 and 32. It's even further. 17.7. Actually, it it needs to be A because it needs to be closest together. So I mean, I don't want to solve questions too technically, but you know, if you truly understood question 29, B, C, D, you know, do not make sense at all as an answer choice. But let's double check, right? Whether 17.3 and 17.7 are in one of these two pairs, right? Let's double check. sea urchin. 자, 갑시다. sea urchin. adenine 32.8이고 time이는 32.1이고요. 이런 앤서 초이스는 없었어요. A, B, C, D 중에. 그리고 guanine이랑 사이토신이 17.3, 17.7. Beautiful. Right? Yeah, great that we double checked. 17.3 and 17.7. 맞죠? 자, 30번 A입니다. 근데 29번을 명확하게 이해를 했으면은 뭐 사실 B, C, D가 답이 될 수는 없어요. 30번에서. 재밌네요. 그죠? Okay, last question. 31. Based on the table is the percentage of adenine in each organism's DNA the same or does it vary? Of course, I thought it was like different figures. Okay, and which statement made by author is most consistent with that data? Okay, 자 그러면 일단 each organism's DNA에 adenin이 같은지 다른지부터 체크를 해봅시다. 자, 그럼 요거 첫 번째. 필기를 너무 많이 해갖고 좀 더러워졌네요. 눈 아프시면 안 되는데. 어쨌든 maize 26 point, octopus 33, chicken 28, 28, 29, 29, 32, 27, 31, 24. So, you know, from 24 to 33, I mean, you know, I wouldn't say it's the same. 그죠? 뭐 24부터 33까지 있는데 거의 10% 차이가 나는데, 그러니까 24%에 또 10%니까 비율로 하면은 그죠? 예, 그런데 뭐 24.7이랑 33.2를 same이라고 볼 수는 없겠죠. 그쵸? same이라고 보는 건 무리겠죠. So it varies. Right? It definitely varies. Right? 그래서 뭐 same도 읽어볼 수 있는데 I don't want to waste your time because this is so clear. It varies. 그래서 일단 vary에서 명쾌한 답변이 있으면 C, D 중에 정확한 답변만 체크해보고 끝내도록 할게요. 자, 그러면은 36 to 38이 이거를 증명해 주느냐 아니면 41 to 45가 이거를 증명해 주느냐 adenin이 vary한 거를 오케이? 자, 그거를 체크를 해봅시다. 36, 38 is C. 조금 크게 늘릴게요. 자, 36. Adenine, for example, can occur on either chain, but when it does, its partner on the other chain must always be thymine. D가 답이었으면 좋겠어요. 그죠? 답 아닌 것 같아. 이게 C인데, 이거는 adenine이 체인이 두 개니까, 뭐 왼쪽이든 오른쪽이든, 뭐 A든 B든 둘 중에 어느 체인에라도 올 수 있는데, 베이스로서. 그런데 페어를 할 때 adenin이 오면 it must pair up with thymine. 이 내용밖에 없어요. 그러니까 질문에 답이 되는 내용이 전혀 없는 게 질문은 each organism's adenine의 percentage가 value가 이 넘버가 다 똑같냐 다르냐를 물어보는 건데 방금 전에 우리가 읽은 line 36 to 38은 전혀 그거에 대해서 답을 해주지 못하고 있죠. 정보가 없죠. 그죠? 그러니까 C는 아닌 것 같고 제가 봤을 때. 자, 그럼 D 한번 볼까요? 41 to 45. So I'll just read from 39 for context, right? The phosphate sugar backbone of our model is completely irregular, but any sequence of the pair of the base can fit into the structure. It follows that in long molecule, many different permutations are possible. And it therefore seems likely that the precise sequence of base is coded with which carries the genetic information. 그쵸? 네, 그러니까 여러 가지로 arrange 될 수 있어서 예, 여기 그냥 다 나와 있네요. 그죠? 예, 여러 가지 방식으로 그러니까 add인이랑 time인이 와야 되지만 여러 가지 방식으로 arrange 될 수 있으니까 그 값이 value가 다를 수 있고 precise sequence of bases is the code which carries the genetic information이니까 이 value가 organism 따라 다 다를 수가 있겠죠. 그죠? 그 organism 고유의 value가 있는 거죠. 다른 거죠. octopus랑 maze랑. So line 41 to 45 give us that answer that adenine can be wrong because it can come in a variety of different arrangement. So it has its own specific genetic information, right? So adenine can vary, can be different based on organisms, based on each organism. The value can be different. 그래서 31번 자, 왔습니다. 죄송해요. 31번 D. Okay, so let's double check. We got all the answers right. 22B, 23D, 24D, 25C, 26B, 27D, 28C, 29A, 30A, 31D. There you have it. All correct. Perfect. Well done. 자, 이렇게 해서 첫 번째 science passage, passage 3, SAT reading, 문제풀이가 끝났습니다. 22번에서 31번. So thank you very much. And the next passage, probably the passage that most number of students struggle with, history passage. Okay? 그래서 이제 다음 시간에는 history passage를 한번 배워보고 가장 많은 학생들이 아마 어려워하는 패시지가 history passage일 거예요. 그러니까 제가 좀 명쾌하게 어떻게 읽는지부터 꼼꼼하게 자세하게 잘 가르쳐 드리도록 하겠습니다. So I hope you join me in my next video when I teach you SAT reading, history passage. Thank you very much for watching and I hope to see you next time. Thank you. Bye-bye.